Today we are going to see when we persist RDD. First point, when we persist RDD. If we take this scenario, in this scenario, first we are loading file. Whenever we load file, it will create RDD. On that RDD, I am applying some transformation. So every transformation returns another transformation. On second RDD, again I am applying transformation. So I will get third RDD. On second RDD, again I'm applying one more transformation. So it creates like this. File loads into x1 RDD. From x1 RDD, we are generating transformation x2 RDD. On x2 RDD, we apply two transformation. One transformation returns x3 RDD. Another transformation returns x4 RDD. So whenever we call x5.a1, this is the flow. This is the flow. File is loaded into x1, x1 to x2, x2 to x3. Yep, started Nalin. Started Prasad, just now started. Reconnect Nalin, Prasad. Okay, so first action, this is the flow, and second action we applied on RDD7. So RDD7 is created on x4. X4 is created on x2. X2 is created x1. X1 is generated based on file 1. So when we in this flow we are applying two actions, right? So this is the flow of first action. This is the flow of second action. This is the flow of first action. This is the flow of second action. So this is called lineage graph. This is called lineage graph. In some interviews, they will ask, write lineage graph. Write lineage graph. So take this example. Take this example. Then first create one lineage graph. In this, it is created two lineage graphs. One lineage graph is contain this flow. Second lineage graph contain this flow. So in this two flows, most commonly used RDDs are x1 and x2. x1 and x2. So if you persist x1, from x1 again we have to generate x2 in both the flows. So if you persist x2, no need of file 1 loading into x1 from x1 to x2. So we save up to this part, we save in both the graphs. So if you execute action 1, it executes on directly x2 to x3, x3 to x5. Here also x2 to x4, x4 to x7. So it reduces what? Loading file into x1, x1 to x2. So these steps are avoided because we persisted this one. So it saves lot of time while processing, right? So if you persist RDDs in memory, it saves execution time. Automatically it improves what? It improves performance of your processing. But we cannot persist all the RDDs, not required. Okay, whatever the RDD is using in multiple times, then persist that RDD. Okay, so let's start transformations in Spark Core. Transformations in Spark Core. First transformation, map transformation. In some interviews, they'll ask, what are the transformations you used in your Spark application development? In some interviews, they'll ask, what are the transformations you used in your application development? Then name some transformations. Most used common transformations in Spark application is map, flat map, reduce by key. We use these transformations many times in our application development, Spark application development. So let's come to map transformation. What is map transformation? So map itself, name itself showing we are mapping something. We are mapping something, right? So map means it will take input as a row and it returns output as a row. It will take one input and return same output. So it is one-to-one mapping, one-to-one mapping, one-to-one mapping. So number of inputs, how many number of inputs we give, we get those many number of outputs. So data size is same. Only one thing, inside this map, we can write a custom logic. We can apply that custom logic in each value. What is the advantage of this map? Inside a map, we write custom logic. That custom logic we can apply on each row. We can apply on each row. For example, we are passing our file contain values 1 to 10. For each row, you want to add 1. Then you can write logic inside map function to add value, to increment value. So like that, we can apply custom logic on input data. So whatever the input you will give, it gives output as same record with different value. So how many records we pass input to map function, it will return same values, same number of values, one-to-one mapping. What is the advantage of map transformation? We write a custom logic inside map function. That custom logic applied at each row of each row of each row. Okay. So let's see. So yesterday we created one. Yesterday we created one imports file, right? Imports.txt. Let's open SBT. Type console. Next colon load imports. Yesterday we created imports.txt file, right? It contains all importing statements, importing packages, creating configuration object, creating Spark context, and setting master and setting application name. Everything is presented in that imports file. Now what I am doing, loading one file, comments file. Let's take comments file in our local path. So in this data, we have comments, right? So if you want to use this entire path, use val rd1 equal to sc.text file, sc.text file, and pass text file path plus comments.txt. So we need to change this parameter slash character, because if you pass this forward slash character, it expect formatting characters like slash and slash t kind of values. So to avoid that confusion, we are giving indication to Scala saying this is not formatting character, this is slash, by adding multiple slashes. Okay, so we created RDD. Then rd1 dot count. So we created rd1, right? So let's open this one, comment.txt, not comments. So file name is comment.txt. Now rd1.count. So we have 4 rows. So before going to pass this one, let's create val r1 equal to sc dot range, sc dot range. I am passing 1 comma 10. So it will create RDD with 1 to 10 values. R1 dot count will get value is 9. R1 dot R1 dot collect dot for each println, for each println, it is printing 1 to 9, right? It is printing 1 to 9. So what I want to do is I want to create every transformation returns another RDD. So R2 equal to R1 dot map, R1 dot map. So X means, so each row is passed to X. Each row is passed to X. Then what I am doing, X plus 1. For each value, I am adding 1. So 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4, 4 plus 1, 5. Like this, we get 2 to 10. 2 to 10. Map, map transformation reads each row, and we apply this custom logic. We write custom logic inside map function. That custom logic applies on each row, each row of RDD. Next, R1 dot count, we will see 9 values only, because input is same, output is same. So but whatever the custom logic we write inside map function, that will apply on value. Let's see. So this is R2. R2 dot count also returns same 9. Now R2 dot collect dot R2 dot collect dot for each. R2 dot collect dot for each println. So observe this data, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? We got 9 values. Okay. So map takes input of same rows and output is same rows. So here, what I'm doing, we created RDD1, right? RDD2 with comment data. What I'm doing, I'm splitting that comment data by using map function. So RD1 dot collect dot println collect dot for each println. So this is the data. Next, RD2 dot collect dot for each println. Observe what it is printing. Let's remove this for each and print RD2 dot collect. Observe, each row is splitted based on space character. Each row is created separate array. Yes or no? Welcome to Spark is created one array. Next row, Hadoop is big data framework. Hadoop is a big data framework is another collection. Next row is created another collection. Next row is created another collection. So each row is splitted into multiple values. Each row is splitted into multiple values based on the delimiter we provide, then written as a collection. Each row written as a collection. Each row written as a collection. Okay. Next, once we got collection, then we apply flat map transformation. What is flat map? What is map? Map reads input and output is same records, output is same records, output is same records with our custom logic. So how many inputs are comment file is? Comment file is presented how many records? 4, right? So we got collection, 4 collections. Yes or no? Output records are same. Output is same. How many rows we pass, those many rows it will return. Okay. Next, coming to flat map. Spark flat map is a function which express one-to-many transformations. One-to-many transformations. Map is one-to-one transformation. Flat map is one-to-many transformations. It transforms each element 0 or more elements. It transforms each element 0 or more elements. 0 or more elements means in a flat map function, we write custom logic. Whatever the custom logic we write, if that row satisfies that custom logic, then only it will return that, value. So here we may have 0 or more elements as output. So it applies to each element of RDD. It applies to each element of RDD and it returns the result of new RDD. So simply every RDD or every transformation returns new RDD. It will not modify in existed RDD. It will not modify in existed RDD. Every transformation returns new RDD. So that's why RDDs are loaded lazy. RDDs are loaded lazily in memory. RDDs are loaded lazily in memory because if you apply multiple transformations, if it is loaded successfully, if all RDD is loaded in RAM, what will happen? It occupies more memory, right? So that's why RDDs are loaded dynamic. Whenever we apply an action, once action is completed, once the result is presented, then memory allocated for RDDs are removed automatically. So if any RDD is using multiple times in our Spark application, then what we will do? We will persist that RDD. Okay. Let's see flat map example. So in previous example, we have collection of each row, right? So in flat map example, what we are doing, we are calling rd2 dot flat map x implies x. That's it. X implies x. So what it will do is it merges multiple collections into a single collection. We have 4 collections, right? It will merges all 4 collections into a single collection. It will read each row and merges. So this is our custom logic. We are merging in a single collection. So first it will read and merges into this one. Next it will read next one and merges into this one. Next it will read next row and merges into this one. So like this, it will read each element and merges into single collection. Let's observe. Now, rd3 dot count. So each value is splitted into multiple words, right? All these values are presented into one collection. So collection contain 21 values. So collection is what? Array, right? Array contain 21 values. So rd3 dot collect. So this is single RDD converted into single RDD. Once multiple collections are merged into single collection, then we can apply map transformation. Why we are applying map transformation means we want to find each word repeated how many times. Each word repeated how many times. For that one, what we are doing? So next one, we are creating pair RDD. We are creating pair RDD. Each word, comma, 1. We are creating what? Each word, comma, 1. So RD3.map means each word, right? Each word. Each word, comma, 1. Next iteration, it returns 2, comma, 1. Spark, comma, 1. Hadoop, comma, 1. Is, comma, 1. A, comma, 1. So finally, it will return 21 pair RDDs. 21 pair RDDs. Let's export. So RD4 dot count, you will see 21. If you use RD1 dot collect, RD1 dot collect, yep. So each word and 1. So it is created pair RDD. It is created pair RDD. So string, comma, int. Each word 1 time. Then we go for reduce by key. What is reduce by key? Reduce by key. Reduce by key, just let me show you. I am applying this one. Reduce by key. Let's copy this one and execute this one, and I will clearly explain here. So what I'm doing, RD4 is this collection, right? So RD4 dot reduce by key. Reduce by key takes key value pair as an input. Key value pair as an input. Key value pair as an input. Okay. What reduce by key will do? Reduce by key reads key value pair. So before applying this key value pair logic, what it will do? It will create grouping operation. It will perform grouping operation, and after performing grouping operation, it will apply this aggregation operation. So whatever the custom logic we write, right, this will apply on that grouping operation. So it will first perform grouping operation. On that grouping data, it will perform what? Aggregation operation. So here, first it will read key value pair. So first it performs grouping, right? And it pass that grouping. So assume welcome. If there is any welcome values, it will read all welcome values and passed as an input to reduce by key. So key is welcome. So welcome, and it passes all these values, one list of values to reduce by key. So first it perform grouping operation based on key. First it performs grouping operation based on key, and then it passes this list of values to reduce by key. List of values to reduce by key. So here assume welcome contain assume welcome contain list of values are 1 comma 1 comma 1. Assume so this list is passed to whom? Reduce by key. First 1 and 1 passed to xy. So 1 plus 1 2, right? 2 is going to store in X. And next, what is the value? 2 comma 1. 2 comma 1. First this value, last value. So 2 is already presented in X. Third value is going to store in Y. 2 plus 1, 3. 3 is going to store X. There is no other list value, right? Then finally it will return word comma 3. Word comma 3. So this aggregation, this custom logic applies on what? Value. This custom logic applies on value. So first it performs grouping based on key and passes list of values to reduce by key function. Let's execute this one. Let's RD5 dot count. So some are duplicates, right? That's why we got 12. Then RD5 dot collect dot for each of println. So each word it displays is repeated 3 times. MapReduce is repeated 1 time. Framework repeated 1 time. Big data repeated 3 times. Let's go and open and check this data. Let's place cursor in framework. Sorry. Place big data. Big data is repeated 3 times, right? Next one. Welcome is repeated only 1 time. Next one. Engine is repeated 2 times. Right? So it finding count. So first what we are doing with this data, we are splitting using map function. We are splitting using map function. Then after that what we are doing, by using flat map we combined. So this map function, inside map function we used a split function. So each word, each row is splitted into multiple words and written as a one collection. So like this we got 4 collections. So to combine these 4 collections, images we are not going to use this one. Images are different, right? How do you apply this word count operation for images? Yep, but this word count is not for images, right? Images we apply different algorithm. Image processing algorithms we apply. Okay. Yep. Scala is extension. Scala supports all Java concepts. So whatever you do with Java, we can include in Scala. Okay. Yep. So next important topic is pair RDD. Pair RDD means if any value contain key value pair, if any value contain key value pairs, then we call it as pair RDD. In pair RDD, first one is called key and second one is called value. In pair RDD, first one is called key and second one is called value. Example, so I have a tuple a comma b. Then I am storing this tuple into RD, RD1. So a is a key and b is a value. So in this pair, a is a key, b is a value. So by default, Spark treats first element of pair is key and second element of pair is value. So reduce by key function groups the data based on key, and performs specified logic on the values of grouped keys. So if you observe here, first we created RD1, right? RD1 is created by loading file. On that we applied map transformation, we got RDD2. On that RDD2 we applied flat map. On that RDD3 we applied again map. So all these operations returns map partition RDD. All these operations returns map partitioned RDD. So this one splitting is written map partition RDD. Okay. Next after that we applied flat map. Flat map also returns map partition RDD. Next one RD4 again map returns partition map partition RDD. Next reduce by key is written shuffled RDD. Reduce by key written shuffled RDD. So this one RD5, right? It returned shuffled RDD. What is shuffled RDD? What is shuffled RDD? So before applying data, let's observe here. So before applying this reduce by key, we displayed RD4, right? So first collection, this is the collection. So this is key value pair, right? This is different key value pair. Let's take a big data key value pair. So this big data key value pair presented in 3 places, right? Assume this key is presented in first partition, big data, and this big data is presented in second partition, and next big data is presented in third partition. So it moves from first partition, second partition, and third partition into one common partition, right? So grouping phase, key is one, and a list of values, it will create a list of values, right? Yes or no? So this data is moving from multiple partition to single partition, right? So this is called, if data is moved from one multiple partitions to some other partitions, then we call it as shuffled RDD. Shuffled RDD. If data moved from one partition to another partitions, one partitions to another partitions, or multiple partitions to one partition, then we call it as shuffling. Shuffling data from multiple partition to one partition, or one partition to multiple partitions. So if you apply reduce by key, what will happen? Internally it will create shuffled RDD. Shuffled RDD. Okay, shuffled RDD. Let's discuss first what is map partitions RDD. What is map partitions RDD? Map partitions RDD. Assume we have partition 1 and partition 2 and partition 3. We have 3 partitions. This one contains some data. This one contains some data. And this one contains some data. This one contains some data. When you apply transformation, it will create equivalent partitions. It will create equivalent partitions. It will create equivalent partitions, and number of connections are same. Number of connections are same. It will create equivalent partitions and number of connections are same. Then we call it as map partitions RDD. If it creates the same partitions, same partitions, but data is moved from this partition to remaining other partitions. Then we call it as shuffled RDD. Shuffled RDD. Shuffled RDD. Okay. So if data is moved from one partition to multiple partitions, then we call it as shuffled RDD. It will internally create shuffled RDD. But here, if data is moved from one partition to another partition and number of connections are same, then we call it as mapped partitions RDD. Mapped partitions RDD. So an RDD generated with one-to-one mapping between its partitions and its parent RDD partitions. This is parent RDD partitions and this is child partitions. If X and Y are two RDDs, if X generates Y and number of partitions of X is equal to number of partitions of Y, and number of mappings are equal to number of partitions. So in this, then we call it as map partitions RDD. Map partitions RDD is the result of the following transformations: map, flat map, filter, map partitions with index, etc. If you apply all these transformations, it will return map partitions RDD. What is shuffled RDD? Shuffled RDD is created while data is shuffled over the cluster. Data shuffled over the cluster. If you use any transformations like join, group by, repartition, reduce by key, which shuffles data, it will be created shuffled RDD. If number of mappings are greater than number of partitions, then we call it as shuffled RDD. Number of partitions are 3, but number of mappings are multiple, more than 3. Then we call it as shuffled RDD. So this is from RDD1, we created RDD2 by using map. On RDD2, we executed flat map. On RDD3, we executed again map. We got RD4. On RDD4, we executed reduce by key. It internally created multiple mappings. This is called shuffling. So procedure 1 we executed previously, right? So first we loaded file into RD1. Then we split the file based on some space character. Next, we merge multiple collections into single collection. Then we created key value pair. Next one, we applied a reduce by key, grouping operation and aggregation operation, right? So this is procedure 1. In procedure 2, we reduce this complexity. Instead of writing multiple statements, we reduce this one into simple. First, we load file into RD1. Then what I'm doing in flat map only, flat map reads one value, right? One row. So you can mention variable name or you can use underscore. Underscore means first row. Dot split. First row we are splitting based on space character. So what flat map will do? Split returns multiple collection, right? Multiple collection. Then flat map combines all multiple collections into single collection. So in a single statement, we are doing map operation as well as flat map operation. Then we are creating key value pair. Next, applying reduce by key. So this is a simple program to implement word count operation. I converted this one into word count operation. Let's use this path, our path. Let's implement this application word count program. So let's write a batch program. So Scala under com.qt, right click on this package, new Scala class, word count, and change class to object. Click OK. Then copy this entire program. Okay. So here cannot resolve SE. Why it cannot resolve SE? Let's make full screen here. Why it is not resolving SE? Can anyone observe and tell me why it is not showing? It's showing SE dot star. Okay. Let's remove this one. Yep. Why it's showing is here. We copied entire thing. That's the problem. That's it. We copied from previous one, right? Let's right click on this word count. Not required to pass command line argument because we pass path. Right click on this one. So run as word count. It will start separate console, not SBT cell. It will start separate console and it displays that one. So let's go word count in data directory, word count, and these are the files, saved files. You got it right? Next important topic is set operations in Spark core. Set operations in Spark core. We have union, intersection, subtraction, Cartesian. Union means combining two RDDs. If you want to combine two RDDs, we go for union. We go for union. Intersection means from both the RDDs, whatever common values are presented, it will return that one. Common values. Subtraction means from first RDD, it will minus common values of second RDD. From first RDD, it will eliminates common values of same for second RDD. Then it returns uncommon values of first RDD. It will eliminate common values from both the RDDs and returns uncommon values of first RDD. Cartesian means it combines both RDDs and returns value. So union means combining two RDDs. Cartesian means multiplying two RDDs. Multiplying two RDDs. Union means combining. For example, first RDD contain 5 rows, second RDD contain 5 rows. We get 5 plus 5, 10. If you use Cartesian, 5 into 5, 25 rows we will get. Intersection means from both the RDDs, common values are written. Subtraction means it will eliminate common values from both the RDDs and return uncommon values of second RDD, first RDD. Okay. We will see this one clearly in tomorrow class. In tomorrow class, I'll take call log data, and I will create multiple RDDs. Then I will apply union operation, intersection operation, subtraction operation, and Cartesian operation. We will apply union operation, intersection operation, subtraction operation, Cartesian operation. Okay. Then we will see clearly uh, each set operation, Okay. Do you have any queries in today's class? Then I'm stopping here, and we will continue tomorrow. Tomorrow we'll discuss complete set operations. Okay. So that's it for today. We will meet tomorrow, and we will discuss set operations in Spark core.